we're asked to find the open intervals over which f is concave up and concave down. To do that, we need the second derivative. So I need to take the derivative of the first derivative. And if I substitute in a value for x and go through the simplification process, the last thing I would do would be that quotient, which means the first thing I'm going to do is the quotient rule. So I can think of this as the low function, and this is the high function. So quotient rule says low d high minus high d low all over, square the bottom, and away you go. Now the complicated derivative is going to be right here. All right, the derivative of that product. So let's go ahead and do that off to the side here. The derivative of x to the 1/3 times x minus 3 to the 2/3. It's very similar to our original function f, except we've got the roles of the exponents different. But we still use product rule like we did before. And we use the power rule. And the derivative of the inside is still 1, so it doesn't contribute anything here when we multiply that. Now I factor out what's in common. So I factor out the lowest exponents. And when I do that, I'm left with x minus 3 plus 2x. And as before, I'm going to get 3x minus 3 over 3x to the 2/3, x minus 3 to the 1/3. And I can factor out that 3 and then cancel it out. And I'd get an x minus 1 over x to the 2/3, x minus 3 to the 1/3. So we get this. Cancel that out. And so that's the derivative of that term. Okay, now thinking ahead, this is what's going to replace this guy right here. So I'm going to go ahead and write this with the negative exponents again, so I'll know how to factor things in the numerator when the time comes. So I'm going to have an x to the minus 2/3. So I have x minus 1, x to the minus 2/3, x minus 3 to the minus 1/3. Okay, so that's what I'm going to replace this with. And then just a quick remark here, the derivative of x minus 2, that's just going to be 1. All right, so in the next frame, I'm going to have substituted in these and then continue to simplify. All right, so here's our second derivative. I've replaced the derivative of x minus 2 with 1, and I've replaced the derivative of the denominator with this guy. And we're going to proceed then as usual. We're going to factor out what I can. So I'm going to factor out an x to the minus 2/3 and an x minus 3 to the minus 1/3. I'm going to look and see what I got. That's going to, once again, when I factor something out, I'm dividing by that thing. And if I divide by x to the minus 2/3, that's the same as multiplying by x to the 2/3. That's going to give me an x there. When I factor this out of this guy, I'm going to be multiplying by x minus 3 to the positive 1/3. That gives me an x minus 3. This is what I factored things out of. I'm left with an x minus 2 times x minus 1. And in the denominator, I can use properties of exponents. That's going to give me an x to the 2/3 there, and an x minus 3 to the 4/3. I just need to clean up what's inside here. I'm going to have an x squared minus 3x, and then it's x squared minus 3x plus 2. And so I have an x squared minus an x squared. That's going to kill that off. I've got a minus 3x minus a negative 3x. That kills that off. So that numerator is just going to be negative 2. And the denominator, well, this is going to go down there. X to the 2/3 times x to the 2/3 is x to the 4/3. This will go down here, x minus 3 then to the 5/3. All right, so that's the second derivative. Okay, here's the second derivative then. We go looking for critical values. So I look where the second derivative doesn't exist. And I'm right in the same place I was before. I have a fraction. I'll set that fraction equal to 0. Go through the algebra, you're going to get x is 0 or x is 3. Now remember, those were places that the first derivative didn't exist. So since the first derivative didn't exist, you know that the second derivative can't possibly exist there either. So, you know, these are like bad pennies. They're not going to go away. Setting the second derivative equal to 0, well, that's not going to get you anything. Because if you clear out the denominators, you're going to get 2 equals 0, and that never happens. So the only critical values we're picking up are x equals 0 and x equals 3. Okay, so here's my second